是第一题。So the first question is about the rule of 70. So if the GDP grows at a rate of X% and X% per year, how long will it take for that GDP to double? And we can calculate that by inputting the rate X into this equation, 70 over X. And so for question A, if the annual growth rate is 1%, how long will it take for the GDP to double? And so now we have the information that the GDP growth rate is 1%. And we just need to input that into 70 over X, this equation. So if the GDP grows at a rate of 1% per year, it will take 70 over 1 years for the GDP to double. And so the answer for question A is 70 years. So now question B, suppose the initial GDP level is Y0 and its annual growth rate is X%. What will the GDP level be after T years? And so now we have the information that the initial GDP level is Y0 and the annual growth rate is X%. We don't know what's X. And so now I'm going to demonstrate how the GDP level grows after each year. So after 1 year, the GDP level will be this. Y0 times 1 plus X% to the power of 1. It's derived from, so when the GDP level grows at an X% rate, we will have the initial GDP level plus the amount of GDP level that grows at X%. So we will have this. And combining both, we will have this. And then after the second year, this is going to be our new initial GDP level, and it's going to be applied the same equation. And so now we have Y0 times 1 plus X% to the power of 2. And it is the same way applied to when the GDP level grows at the same rate after 3 years. And so we see a pattern here. From the first year, there's the power of 1. Second year, we have the power of 2. And the third year, we have the power of 1. And so we can conclude that throughout these patterns, the GDP level after T years is Y0 times 1 plus X% to the power of T. Okay, and so for question C, if T is continuous, explain why the GDP level after T years can be represented as an exponential growth function. And so from this question, we have two keywords. One is exponential and continuous. So when we hear the word exponential, we're going to think about E, the Euler's number, 2.71 and something. Next, the keyword continuous. It means that taking the limit of a function as a variable approaches infinity. That's what you're going to do to solve this question. And so the function, what we mean as the function is this function, the function that we got by answering question B, and the variable is t, because from the question, if t is continuous, so the variable is t, approaches infinity. And so we're going to take the limit of this function as t approaches infinity. And since y0 is a constant, we can move it to the left side. And to proceed to the next step, we need to remember that this is the limit definition of E. And so we need to make this, our original equation, into something that fits into the pattern of this. And so let's assume that this x% is 1 over x. And since we have the power of x, which is the inverse of 1 over x, we're also going to do the same thing to this equation. So the inverse of x% is 1 over x% times t. And then we're going to multiply with x% again, because technically this part has to equal to t, just like the previous line. And so we are going to make this into something like the limit definition of e without changing, without being different from the previous equation. And so here we have y0 and then the limit of this function as t approaches infinity. And therefore here we have this part of the solving process, and this fits the limit definition of e. Now it's the same, and so we can bracket this and write it as e and leave the rest as the power. And so at the end we'll have y0 times e to the power of x% times t. And now part D. Using your answer from C, derive the mathematical proof for the rule of 70. And so we're going to write our equations there. And so the rule of 70, we need to be reminded that it is used to calculate the time for how long the GDP level is going to be doubled with a certain annual growth rate. And so we're going to set the y of t equals to 2y0 because it's going to be double the initial GDP level. So 2y0 equals to y0 times e to the power of x% times t. Now we have y0 on both sides and we're going to divide it, we're going to eliminate it. And we're left with 2 equals to e to the power of x% times t. And the focus here is we're going to find t, right? We're going to prove that t, to find the time, we need the rule of 70, which is 70 over x. And so to find t, we're going to use a natural logarithm. We're putting ln here on both sides. And then with the natural logarithm law, we're going to move the power to the front. And so now we have ln 2 equals to x% times t times ln e. And at this part, we can ignore ln e because it's equal to 1. So it's basically ln 2 equals to x% times t. And so to find t, we're going to remove this x% here. And so t equals to ln 2 over x%. And since x% equals to x over 100, we can change this, change x% into x over 100. And then it's equals to ln 2 times 100 over x. And then since ln 2 is approximately 0.693, we can make this sign, and it's close to 0.7 times 100 over x. And this is how we can prove the time is required for an amount of GDP, and then the initial GDP level to double with a certain growth rate is calculated by the rule of 70, which is 70 over x.
First, we will look at the question like the cost of producing 8 units of a product at TSM company is C equal to A plus 2 the square root of A plus 5. So the first question is we have to find the fixed cost FC, also we have to find basic variable cost and also marginal cost MC. So what is fixed cost? Fixed cost is the part of the total cost that doesn't depend on the production quantity X. It means the constant X. So in that total cost function, the fixed cost is 5, so FC is 5. And the other one, VC. VC, variable cost. Variable cost is the part of TC that changes with the production quantity X. It means VC in that total cost production, VC is X plus 2 the square root of X. So the third part is MC, marginal cost. MC is the derivative of TC function C of X with respect to X. MC means we have to derivative function. So when we differentiate the total cost function, we got 1 plus 1 by the square root of X. So for the second part, part B. In part B, the question asks what is average fixed cost AFC and also AVC and ATC. So what is AFC? AFC is the total the fixed cost divided by production quantity X. So when AFC is FC, fixed cost divided by X. When we got, in part A, we already got like fixed cost. So fixed cost is 5 divided by X. So this AFC function. So ABC is VC divided by production quantity X. And we also got like variable cost. So variable cost is X plus 2 the square root of X by X equal to 1 plus 2 by the square root of X. So the last part, like ATC function. ATC is total cost TC divided by production quantity X. So C of X function is X plus 2 the square root of X plus 5 divided by X. So we got the ATC function is 1 plus 2 by the square root of X plus 5 by X. So for the third part, part C, we have to find horizontal asymptote and vertical asymptote of ATC cost function. We have to look at the ATC function. So we have we first find like horizontal asymptote of ATC. So to find the horizontal part, to find the horizontal asymptote, we have to compute the limit of ATC as x approaches infinity equal to when we substitute ATC function here and we got y equal to 1 is horizontal asymptote. Why? Because how can you say that like 2 by the square root of x, also 5 by x is approach 0 as infinity. It means we got like 1 equal to 1 horizontal asymptote. So the second part, we have to find vertical asymptote. So vertical asymptote, when we first write the ATC function here, and we look at like the function is like defined for like x is always like greater than 0. So it can be no vertical asymptote. So the answer is no vertical asymptote here. So let's go to the next part. So the last part is we have to not find and prove. Prove what? Prove MC equal to ATC at ATC's minimum. Also, we have to use the concept of relative extrema. So, and they give this like MC equal to DC by dx, comma ATC equal to C of x by x. So, how can we find it? First of all, we have to recall the formula. Like ATC is equal to C of x by x. And to find the ATC minimum point, we have to find the first derivative function of ATC. So we have to use the quotient rule. So when we use the quotient rule, we got this answer: x dc by dx minus C of x minus x squared. And as we know, MC equal to dc by dx, or here dc by dx, so equal to MC. So x MC minus C of x by x squared. And we also have to use the concept of relative extremers. So we have to find like ATC's like minimum point, or we have to find the critical point. So we have to set the like derivative function of ATC equal to 0 here. And the derivative function ATC is like x MC minus C of x by x squared equal to 0. Then we got this answer. And minus C of x go to the other point, go to the other go to the other side, it will be x and c equal to c of x. Also, this x go to the other side, it will be mc equal to c of x by x. Oh, c of x by x is equal to 80c. So we got mc equal to 80c. The end.
好，第三题，这里是你在寻找的中文留言。好，那我们知道第三题，它基本上想要第一个题目，它想要 What is the relationship between these two types of calculators? Use calculus to explain your answer. 好，那今天为什么我们要以就是对 P2 去做偏微分呢？因为 Q1 呢，如果我今天对 P1 做偏微分，那其实我只会得到 P1 的一个结果。那我们今天想要干嘛？我们今天想要找的事情是 What is the relationship between these two types of calculators? 所以干嘛？我们需要对 P2 去做偏微分。那我们得出来的结果是-3。那我今天一样的结果就是我今天对 Q2 呢对 P1 去做偏微分，那我得出来的结论是-3。那我们知道说，我们可以从这个关系式得出什么样的一个结论呢？就是我们知道说，好，当我今天 P2 单价上升的时候，我 P1 的需求量就会上升。那我今天 P1 的单价上升的时候呢，我 P2 的需求量就会下降。好，那从这个时候我们就会观察到一件事情，就是不管哪一个单价的上升，都会影响到另外一个东西的需求量。那这时候代表什么？这两个 calculator 它们就是什么？它们就是互补品。好，来，第一题呢，我们要干嘛？我们的题目是 Find the total revenue function。那这时候我们一般而言，我们会怎么寻找 total revenue 呢？基本上都会是 P1 乘上 Q1 嘛，就是我们要price 乘上 quantity。那我们的 B 选项干嘛？就会是 P1 乘上 Q1 加上 P2 乘上 Q2。那这时候我们会得到我们的一个关系式，就是-6的 P1 平方整掉-6的 P2 的平方整掉6的 P1 乘 P2 加上66的 P2 加上78的 P1。好，那第 C 呢 ？What prices P2 and P1 should be charged for each product to maximize total revenue？ 好，这时候我们要怎么做？我们需要对 P1 去做偏微分，跟 P2 去做偏微分。那从这个结果，我们就可以得到 P2 是等于3，那 P1 会等于5。那因为刚刚题目呢，我们有知道说它干嘛？它需要得到的是 a multiples of 10， 所以这时候我们得出的结果需要乘以10。所以真正实际上的结果是 P2 呢其实是30元，那我们的 P1 呢其实是50元。好，那主选项 What are the revenue maximizing quantities Q1 and Q2 respectively？ 好，那这时候我们干嘛？我们就要带回去我们一开始的式子嘛。所以这时候就是干嘛？78乘减掉6乘上我们刚刚算的数字5，跟3乘上我们刚刚所算出来的 P2 就是3，那这时候得到39。那 Q2 也是一样，那我们就得到33的结论。那因为我们的单位是什么？我们的单位是百，所以我们的一选项 What is the maximum total revenue？ 那这时候就会是50。那我们刚刚算出来的结论就是50，然后再乘上3900，因为我们的单位是百。那50乘上3900加上30乘上3300，那这时候就会是这个数字呢，就会是我们的 total revenue。好，
接下来呢，我要来讲解的是第4题。先来大概叙述一下题目。在题目当中呢，有2种商品，分别是 X 跟 Y。对这个消费者来说呢，它的效用可以用根号 X 加 Y 来表示。首先 A 小题要求的是画出一条由X 跟 Y 组合而成的曲线，而且效用要等于200。看完题目之后，我们可以列出一个等式，就是根号 X 加 Y 会等于200。然后我们把它画成 Y 等于200减根号 X 的形式。我们可以先取几个点，像是0、200、1、199跟4、198。然后呢，我们要来判断一下这条曲线它大概的趋势会往哪里走。我们可以透过一阶微分来判断，一阶微分过后 dy 除以 dx 会等于负的2根号 x 分之1。我们可以由此得知，当 x 变大时，曲线的斜率呢会慢慢的变平缓。再来是二阶微分，二阶微分过后，它的结果是1/4乘以 x 的负2/3次。然后呢，就是它代表是无论 x 等于多少，这个值都横正嘛，所以我们可以得出这个曲线的凹口向上。取完点， 知道随 x 增加曲线会逐渐变平缓，以及它的凹口向上，我们就可以画出这一个图了。再来是 B 小题，在经济学当中呢，这条曲线称之为无意曲线。在无意曲线上呢，消费者对于不同商品组合的效用，也就是偏好程度会一样。下一题 C， 题目要我定义边际替代率以及用微分的方式去描述它。边际替代率 MRS 呢，表示在效用不变的情况下，消费者为了获得额外一单位的 X 而愿意放弃多少数量的 Y， 其实也就是无意曲线的斜率。所以我们可以把它的公式写成 dy 除以 dx。在这题呢，y 等于200减掉根号 x， 代入之后呢，我们可以算出这一题的边际替代率会等于负的2根号 x 分之一。D 小题呢，要来定义的是 x 跟 y 的边际效用，以及用微分的方法来描述它。x 的边际效用呢，我们可以用 MUX 来表示，它的意思是呢，当 x 增加一单位时，对于效用会产生的影响。我们可以用 u 对 x 的偏微分来计算。这一题呢，我们算出来的 MUX 会等于2根号 x 分之一。y 同理可得，可以用 MUY 来表示它的边际效用。意思也就是当 y 增加一单位时对效用所产生的影响，它也会等于 u 对 y 的偏微分。这一题呢 MUY 会等于1。接下来呢是最后一题，最后一题要证明 MRS 会等于负的 MUX 除以 MUY。依照题目我们可以列出 u 等于根号 x 加 y， 然后呢我们要用到全微分的技巧。全微分之后呢 du 会等于 u 对 x 的偏微分乘以 dx， 再加上 u 对 y 的偏微分乘以 dy。然后呢，因为无意曲线上效用不变嘛，所以呢 du 会等于0。前面也有提到 MUX 等于 u 对 x 的偏微分， MUY 会等于 u 对 y 的偏微分，所以呢替换之后我们可以得到一个等式 MUX 乘以 dx 加上 MUY 乘以 dy 会等于0。题目所要证明的是 MRS， 然后呢我们的 MRS 又等于 dy 除以 dx 嘛，所以我们就要把这个等式化成有 dy 除以 dx 的形式。移项之后呢，我们可以得出 dy 除以 dx 会等于负的 MUX 除以 MUY， 也就是题目所求的所要证明的 MRS 会等于负的 MUX 除以 MUY。
讲解第5题，那 A 小题要求的是它的预算线，那它的总预算是8100元，那90是代表电视广告，后面的未知数是它的数量，那36是报纸广告，45是收音机，然后我们总共列出来的算式就是它的个别成本乘以它的数量加起来会是它的总成本。那 B 小题是要求它的3个未知数，就是它们个别广告种类的这个数量，然后这个方程式会受限于刚刚我们列的这个预算线，那我们就用拉式乘数来列式，会长这样，然后再个别做它们的偏微分，之后我们会得到就是 t 等于4/5，然后 r 等于6/5，然后再带回这个方程式，会解出 t 等于40，p 等于50，跟 r 等于60。那 C 小题是利用我们刚刚算出来的未知数，然后代入它的原式，就可以解出它的这个最终会得到结果是371。